Hi everyone, let's complete the last page of our notes. First we're going to define the number e. Yes, I said it, the number e, which is defined to be the limit as x approaches infinity of 1 plus 1 over x to the x. If you do this out, then you'll see that it equals approximately 2.718. You might say, shouldn't that go to 1 or infinity or something? Well, turns out 1 plus 1 over x gets really small as x gets big. X gets really big in the exponent, and somehow it just sort of evens out to be a number a little between 2 and a little bit less than 3. Between 2 and 3, right? One place where you see e come up is in compounded interest, right? If you have infinitely many compounding periods, then you actually use this number e to figure out the amount of interest that's charged. But anyway, let's just do a couple of quick examples involving e. We're going to see later on why it's really important. But for right now, just treat it like a number, like the number 2 or something. Right, so find the limit as x approaches infinity of e to the negative x. Well, the first thing to notice is that anytime you have a negative exponent, that's the same as 1 over the number to the positive exponent, right? Now remember, e is just some positive number, right? So as x gets large, e to the x gets large. So our answer is 0. Maybe actually I'll write it down here. Right? This gets large as x gets large. So top stays the same, bottom gets bigger. We get 0. We're done. Right? Similar to this, right? Let's be a little careful here. We're approaching negative infinity right there. Let's be a little bit careful here. But let's see what happens. As x approaches negative infinity, 1 over 1 plus e to the 3x. So remember that anytime you raise a positive number to a negative power, we're talking about 1 over that number to a positive power. So we talk about raising e to the negative 100, negative 1,000,000, negative 1,000,000,000, 1 over e to that tiny, tiny number, right? Which we just said was 0. So this approaches 1 over 1 plus 0, which is just 1. Okay? Let's skip example 8 for right now. Maybe we'll return to that the next class. Example 9, though. Let's take a look at example 9. We have the limit as x approaches infinity of 1 minus e to the x over 1 plus 2 e to the x. So what's happening here? Well, if we try to just find the answer, you see that we're going to get negative infinity over infinity, right? E to the x is blowing up, so 1 minus e to the x is blowing up in the negative direction. And 1 plus 2 e to the x is blowing up in the positive infinite direction. So what we can do, similar to what we did with polynomials, let's divide the top and the bottom by e to the x, right? Indeterminate form, right? Infinity over infinity, negative infinity over infinity, right? We just approach it the same sort of way, right? E to the x is what's complicated, so let's get rid of it in the numerator in a sense, right? So we have 1 over e to the x, or e to the negative x, minus 1 on the top. And on the bottom, we're going to have 1, I guess it's going to be 1 over e to the x plus 2. Now remember, we already said that 1 over e to the x approaches 0. So we know that this is going to be 0 minus 1 over 0 plus 2. So our answer is negative 1/2. There you have it. A couple of little examples with e to the x. Also, just to prepare you for our Friday's class, on a separate note, if you look at example 8, just one thing to note. The limit as x approaches infinity of sine of x. Well, let's just take a look at the graph of sine of x, right? Hopefully we remember this from trig class, but sine of x looks like this, right? It oscillates between -1 and 1. So this is kind of an unusual example where there is no limit because it doesn't really settle on anything, right? Anytime it approaches a value, sooner or later it's going to go away from it. So this is one of these weird cases where the limit does not exist, and it's not because it's infinite, it's not because the left and right hand limits don't equal each other, it's because it just never gets arbitrarily close to a number as x gets arbitrarily big. And there you have it. That will be a bit more relevant for tomorrow's class, so just stay tuned.